Recently, Houdini added support for Gaussian splats, but you can't relight them at the moment, until today. I made a basic workaround that supports dynamic lights and dynamic models and any other things you want to do. It's pretty easy to set up. You just take the unlit model and you turn it into a proxy mesh, then you bake the lighting into that proxy mesh, and then you transfer the lighting back onto the splats again. Now splats have parts that are like diffuse and parts that are like specular, and you can choose to treat the specular differently to the diffuse if you want. And I've also made some visualizers to view those components and let you recolor them. You can download all this on my website, but for now let's get on with the video. Right, so the first thing we need is a splat model. And I don't have one myself, so I'm going to steal one from someone else. I'm going to go to Super Splat. Now if you go to here, you can take downloadable, and it can show you all the ones you can steal. Now, when you're looking for a model, there's different characteristics you might want to do. For example, this car wouldn't be a very good model to use because this lighting is very harsh and very directional, and so it's not going to work very well if I try to relight it. Whereas something like this field, where it's got more ambient lighting and not too many shadows, that's going to be much easier to relight, and it's going to look a lot more convincing. The problem with this one is it's really big. It's 130 megabytes, and Houdini is not stable enough to support this kind of thing at the moment, but that might change later. So for now, I'm actually going to use a model from this user called Scant3D. This user has a bunch of these bug models that I quite like, that have quite neutral lighting, and they're all very small as well. They're only 5 megabytes. So this one has some nice hair detail, and it's going to be a good example that I can use. So the license means I can use it in this video, so I'll download this PLY file. So now I've got this file in my downloads folder. I'll go inside the zip file and it's got the PLY. I'll just put that in my downloads, and I might rename it just to bug splat. So now in Houdini, and I'm going to add in a new geometry network, and in here you can load it using a file node. So the file node, you set it to load bugsplat.ply, and there is my bug splat. The first thing you need to do, drop in a bake gsplat node. If you plug it in, it's going to suddenly look like it's supposed to because it's upside down. I'm going to rotate it back around again, 180 degrees, and now it's sitting the right way up. Now one thing to know about this node is it adds an orient attribute, and this attribute is only correct for the original orientation, and that means if I was to transform it before doing this node, it's going to look a bit weird. You can see this sort of weird rotation compared to if I do it afterwards, it's going to look completely normal. So what really is a Gaussian splat? It's just a bunch of points. Each of these blue dots is a point, and each of those points has a little sphere on it. For example, if I zoom in here, you can see these little spheres, and they look different because they have this attribute called GS alpha, Gaussian splat alpha. Now at the moment, these splats only have a color attribute, CD. That means that I can change the color, for example, using a color node to set it to be red or white. But the problem with just having CD is it doesn't change depending on the viewpoint. You can see it more with these splats that I found, where this orange one, for example, doesn't change depending on the view. Now if you tick compute SPH coefficients, you'll notice this thing changes color now. So why is that? Well, now it's got another attribute called GS-SPH, and it has 3 of these attributes for red, green, and blue. And each of these contain factors of how much the base color should be distorted in different directions. And that means you can fake stuff like specular lighting, where it changes depending on the viewpoint. The other thing with these SPH attributes is they take priority over the CD attribute. So if I was to recolor, it's not going to change it now because I've got those coefficients, whereas if I don't have them, it will work. But that's okay because later on I'll recolor both CD and the SPH attributes. So keep SPH enabled for now. Since we need to recolor the SPH values, I'll tell you what they represent. Each contains 16 numbers. The first number is the base color. This doesn't change depending on the view angle, like diffuse lighting. The other numbers change the base color depending on the viewpoint, like specular lighting. There's a visualizer on my website you can copy to see the effects of each of these things. Then go back to Houdini and add in a point wrangle, connect it, and inside the wrangle you can paste that code in, press the create parameters button. If you set it to 1, it'll view just the diffuse component. That's the part that doesn't change. Now the second one is just the specular color, and this has an option to change the midtone. And then the final one is the specular magnitude, and this is like a shininess map. And this is telling me there's going to be a lot of change in the hair of this creature. So anyway, back on track. First I'm going to just rename this node to Viz, Diffuse, and I'll color it blue. So next I want to make a model to represent this splat, and to do that I'm going to be very lazy and type in particle fluid surface. Now, this is not going to give me a very good result by default, and I chose this model for that reason. And if you make it a bit smaller, you'll see all these strange looking shapes. And this is not going to work for lighting because it's going to have very strange looking lighting. So I want to clean this model up. And to do that, I like doing it this way. The first thing I'm going to do is delete any points that are very transparent, like down here. The fluid surface doesn't know these points aren't important and it might mesh them. So I'm going to drop down a blast node and I'm going to connect that and set it to points. And then for the group, I'll type in @gs_alpha is less than 0.1. And that's just saying if the alpha value is under 0.1, just remove the point. I might do 0.15. And that's just going to clean up a few of those tiny points. But the other problem is sometimes you have very thin cylinder looking things like this. To clean those up, I'm going to use a different approach. You'll notice that these points have an attribute called scale. And that means I can copy something onto them and it'll be stretched out to the same shape. For example, if I take a box like this and I use copy to points, and then I plug in the splats and plug in the box, it's going to copy a bunch of these thin boxes onto the points. Now, if you have a very big model, this will crash Houdini, so you might want to skip that step. But for this model, it works pretty well. And make sure to set the box size to 2, so it's the correct scale. And next, I'm going to fill up these boxes with points using a node called points from volume. Now, you might want to set this high in case it crashes Houdini. What that's going to do, if I enable the point visualizer, not enough at the moment, I'll make it a bit lower. There we go. Now you can see there's points being scattered inside of those boxes. I'll set the jitter scale to 1 because I want them to be randomly spaced. And I'm going to lower the particle separation until the arms get filled out. So I might do 0.02. So that's looking pretty good. I might go a bit lower, 0.015. There we go. And this should work a lot better because if you look at the original point cloud, it's very sparse in these areas. And this trick has just helped fill up that area with more points. And that's going to mean the fluid surface has a better idea of where the geometry really is. So I'll plug that in and I'll try again. Alright, so that's looking a bit better, getting rid of some of that crap that we had before around the head. But there's also these floating points around here. Now, I'm going to do this after the meshing, but I also want to set this to be surface polygons, because polygon soup can be very laggy. Then there's a labs node called delete small parts. You do need labs installed to use this, but it's quite a good node. It just deletes all those tiny floating pieces and cleans everything up. So this is looking a lot better. The main thing you want to avoid is holes. So holes like this are always a big problem because the lighting is going to look really strange. And the other thing you want to avoid is interior gaps. So if I go to the wireframe mode and look inside, you can see there's all this weird looking crap. And you don't want any of this inside. So I'm going to go to this fluid surface node and I'm going to increase the separation. So the inside now looks a lot cleaner than it did before. And this is the sort of result you want. So I'll go back to the smooth shader mode. And then after that, I'll add in a normal node and I'll set the cusp angle all the way up. Now, something else you want to look out for is these weird little spots like this. The reason for this is the topology in these areas is going to look really weird. It's got this weird triangle and quad going on, so it's causing this weird normal. And that's a result of this fluid surface node. It has a setting called adaptivity. And adaptivity basically turns everything into an approximate mesh. And it can cause a lot of shading problems like that. So I recommend using a very low value for the adaptivity. For this model, I'm just going to set it all the way to 0 because I wanted to not have any of those problems. And so this is going to be the final model for the moment. Now the next step is UVs. I'll go back to smooth shaded mode. Because we're baking the texture, it needs a UV map so it knows where to bake the lighting. To get the UV map, you can just use a UV unwrap node. It'll give you a fairly crappy looking UV map. And now I'll just go from perspective to UV viewport. And you can see it's very, very tiny looking tiles. And that's because the spacing is very high, so I'm going to decrease the spacing. The main thing with the UV map is trying to get as many of these big tiles as you can, because the lighting is going to be continuous across those tiles. Whereas if you have these little smidgy looking tiles, it's going to have very discontinuous lighting. So it's not going to look as smooth. The other thing you want to avoid is overlaps, like here, where the lighting is going to overlap with its itself, that's not going to look very good. For this UV map, it's also very spaced out, and we can fix that using a UV layout node. The UV layout node tries to pack everything as close together as possible, and it may take ages if you have very complicated UVs. Actually, to reduce the complexity a bit, you can set the planes from 6 to 4, and that should reduce the amount of small parts. So now I'll preview the UV layout, and this will take a second to run. Right, so now the UV layout's completed. You can get slightly better coverage by setting the rotation step. Rotation step means it'll try different rotations to see what fits the best. I'll set it to 11 degrees. And for now, that's going to be good enough for our purposes. There are some other things you can use to make UVs as well. For example, there's one called UV flatten from points. And I'll show you what this node does just quickly. If you add in some points, scatter them on the surface, use those as the second input, and plug that into the first input. Then you set this to be the point source as the second input. Right, so it just finished processing, and you can see what it's done is generate all of these tiny little islands. So I probably scattered too many points. I have 1,000 points, so there's 1,000 islands. But you can see it's kind of continuous, and you don't get as many gaps as you do from the UV layout. But this took 10 minutes to calculate, so I'm just going to stick with UV layout for now. So now we've got the UVs, we can cache out the model using a file cache node. I'm going to connect it in, and I'm going to name it REST proxy, because I'm going to animate this later on in the video. On this, I'm going to untick time dependent cache, because it's not moving at the moment, and then I'm going to do save to disk. And now we've got that saved to disk. And now we can load this into Solaris to start setting up the lighting. So now I'm going to go from the build tab to Solaris. And Solaris is where I'm going to be rendering this in Karma. The first thing I want to do is import that proxy using a SOP import node. Drop this down, and for the SOP path, I'm just going to pick the cache that I had, REST proxy, accept. And now I'll go to the camera, and you can see we got this proxy that's called SOP import 1. And I'm just going to rename this to proxy geo. And now I'll just set up some basic lighting. So I'm going to add in a light, then connect it to the bottom, and you can add in any kind of light that you want. I'm just going to add in a distant light, and I'm going to make it very, very bright. So exposure maybe 20, 16, something like 16. And I'm just going to have it shine maybe on this side of the Beetle so you can really get the effect of the lighting. So now let's see how that looks if I render it. So I'm going to switch from perspective to Karma XPU. And it's looking not particularly remarkable, but it should work for this video. So now I want to add a material to this guy. I'm just going to make a blank white material. So I'm going to make a material library, drop it down, connect it in. Inside the material library, I'm going to type in Karma Material Builder. I'm going to drop this in. Now I'm going to name this just white material. Then inside here, I'm going to go to the surface. For the color, I'll just set it to fully white, so 111. And for the specular, the roughness is very low by default, so I'm just going to make it a little bit higher, like 0.5. Then I need to assign this material to the bug to see what it's doing. On the material library, they have an option to do this called material path. For the material path, I'm just going to type in white matte, because that's what I called it before. And I'll take assign to geometry and drag in the proxy geo. So now it's assigning that white material to the proxy geo. So now we're ready to bake this lighting into a texture, and baking is only supported in Karma CPU at the moment, not Karma XPU. And to bake it, you can use something called the Karma Texture Baker, which I'll drop down just here. Now make sure you bake the texture after the scene is completely set up, because all the shadows and reflections from other objects in the scene you want to include in this texture as well. So I'll connect this in, and now I'll display this Karma Baker. On the settings, you can set the baking mode to single mesh, because we've only got this one mesh, and I'll drag in the proxy geo as the low res mesh. Now you get this texture. Now at this point, if you see completely black, you might need to update Houdini, because this node was broken until very recently. Or you might need to make sure you're in Karma CPU. If you're in Karma XPU, it's not going to work properly. And the other thing I'm going to do is set the camera to be the texture bake camera. So now we're getting a box which is the proper resolution of the texture. So this texture is because it's baking the tangent space normal. I don't want the tangent space normal, I'm just going to untick that. The other thing I'm going to untick is the alpha, because I don't need that either. What we want to bake is actually the lighting. So if you go to the lighting tab and tick enable lighting, now you can pick the ones you want to bake. The one you do need is combined diffuse, so I'll tick that. What the fuck? Right, so I just restarted Houdini and now this node is working again. So keep in mind, this node is not the most stable thing. We've got the color, we've got the combined diffuse. The other one we might need is the specular. And they don't have an option for the specular yet. But there is this giant list of light path expressions you can find in the description. The one for specular is called combined glossy reflection. So if you copy this expression, go back to here. In the extra AOVs, I'll do plus. Then the AOV, I'll call it specular. Then for the source name, I'll paste in that expression. So now we've got the color, we've got the combined diffuse, and we've got the specular. Now keep in mind the specular is view dependent. Diffuse doesn't really change depending on the camera angle, whereas the specular does change depending on the camera angle. And that means if you bake the specular to a texture, it's not really correct because it's only one view of the object. So anyway, let's bake out these textures. I want to set the image format from PNG to EXR because EXR has high dynamic range. And that means if I have very bright lights, they don't get completely blown out. For example, if I view color correction and I decrease the brightness, you can see there is still data there, even though it looks completely blown out in the viewport. Then for the output picture, I'm not using UDIMs at the moment, so I'm going to remove the UDIM and I'm going to add in the frame number like this. And that's important later if you want to have an animated object because you need an image for each of the frames. The last thing I might do is turn on the denoiser. So I'll set the denoiser to open image denoise, and then for the AOVs I'll just do a star so it denoises everything. And on the USD render, I'll just render the current frame and I'll render it to disk in background. That opens this little pop-up that says you can view the scheduler, and this says how much is done. So it's on 10%. Alright, so now the job's 100% done. If I go to my downloads folder, there's a render folder next to the HIP file, and it's got the color output, the combined diffuse, and the specular. So I'll close this, and then I'll go back to the build again. And now I'll just go from stage to OBJ as well. So now everything's back to normal. And now I'm just going to preview what those textures are going to look like. So if I do UV quick shade, then I'll set the texture map to be one of the images in the render folder, for example, C. Now that is the baked lighting. And you can see the specular map is slightly darker. And there's a few weird patches here, which is the consequence of the UV map being a bit crappy. But for now, this is good enough. All right, so now how do we transfer this lighting onto the splats? Well, you're going to have to jump over to my website. There's a relighting section. And in this section, there's this giant script that you can copy. So going back to Houdini, I'm going to add in another wrangle. I'm going to paste in all of that script and I'm going to press add parameters. Now you have some parameters for the texture, the color space, and the mix. And I'm just going to plug this into the splats. So I'll move all this crap over here. And I think this was the original splat model. So I'll connect that down. And then the second input is the thing that has a UV map on it. I'll plug that into the second input. So nothing's changed at the moment because we need to set up these settings. And to do that, I'm going to click here and do edit parameter interface. For these diffuse texture ones, I'm going to set the type to type image. Then for these two integer sliders, these are meant to be toggles. So I'll change these to be toggles, apply and accept. And now we have everything set up. So the diffuse texture, we pick the texture called combined diffuse. And for the specular texture, we pick the specular. Now we can increase the diffuse mix. And as we increase it, you can see the lighting beginning to come through from that texture. Then the specular mix, you see a small change. And if something doesn't look right at the moment, it's probably because you don't have the spherical harmonics attributes. Like if you didn't tick this SPH, it's just going to draw the lighting. But if you tick this option, it will work. Now you can leave this unticked. The only thing you need to worry about is making sure these don't exist afterwards. So if you do attribute delete and you just do GS, one of these GS attributes, it'll fix that problem. And it'll just be using the CD color instead. So I'll go back and re-enable those coefficients. So what is this script actually doing? Firstly, it's taking each of these points and it's looking up the nearest UV coordinate and it's using that coordinate to read the texture. That means it's not dependent on the resolution of this geometry. Then it loads in those colors and it multiplies the diffuse and it multiplies the specular by those textures. And it also has some attributes you can use as AOVs when you're rendering, and I'll get into those later. But for now, the settings you might want to look into is scaling the specular by the diffuse. And all that's doing is replacing the specular texture with the diffuse texture. And that just gives the same result as doing this. And you might want to do that in cases where the specular is very weak and you want it to be much stronger. or if you think that having the specular baked isn't very physically accurate. The other option is adding the specular to the diffuse, which can help brighten the object, but it's not physically accurate to do that. And then of course there's the diffuse mix, which just makes it darker or brighter, and there's the specular mix that just makes the highlights stronger. So that's the basics of what this does. For the color space, if it's an EXR file, you can use linear. If it's a PNG file, you might need to use sRGB. But to be safe, you can use auto for both of them, and that should be the default anyway. So now we've baked in the lighting, we're ready to render this in Karma. So I'll add in another file cache node, like before, and I'll call this rest splats. Now I'll untick time dependent cache, and I'll do save to disk. Now I'm going to load this splat differently in Karma for slightly better performance. I'm going to go to the Advanced tab, and I'm going to copy the file path, so copy parameter. So now I'm going to go back to Solaris, and it's put me in the wrong view. I'm just going to go to the stage, and now I can import the splat, but I'm not going to use SOP import this time. I'm going to use a different node called geometry sequence, and in the geometry sequence I'm going to paste in that path, and I'll view that. And the reason I'm using geometry sequence is so Karma can render this directly instead of converting it to USD every frame. So that's going to make it a bit faster. To render this, I'm going to just connect it down here, and now I've got two overlapping models. And I actually want both of these models to render because I can use the proxy model to cast shadows on the environment. Splats can cast shadows themselves, but it's very slow. And actually there's an option on the node that's called disable shadow casting in Karma, and it's enabled by default because it's so slow. So now let's get into rendering this. At the moment, splats are not supported in Karma CPU, they're only supported in Karma XPU. So if we go to Karma XPU, you're going to see the splats, and you're going to see this proxy model. Now I'm going to add in some geometry just to check the shadows. If I add in this grid, you can see that it's casting a shadow, whereas if I don't have that proxy geometry there, it's just going to have the splats, and those splats are not going to be casting a shadow because we disabled it. So to get this proxy geometry to cast that shadow, I'm just going to make it invisible to all the rays that aren't shadow rays. To do that, you can use a node called render geometry settings. If you plug this in, what I can do is take my proxy geometry, drag that into the primitives, and then under shading, I'm going to set the render visibility, and I'm just going to type in shadow. So now it's only being used to cast shadows on the environment. So now we're getting shadows and lighting, but maybe you want to update the lighting. And you'll notice that if you add a new light to the scene, it's not going to update the splat because we've already baked the lighting. But what if we want to update the lighting? The first thing you want to do is make sure that everything you want to influence the lighting is included. At the moment, the grid is not included because it's not plugged into the texture baker. So if we connect it in, now the underside of the bug should be in shadow once it's baked out. So now let's just bake everything out again. So now I'll go to USD render and I'll click render to disk in background again. I'm clicking the background just so it opens this scheduler because otherwise you don't know how long it's taking. Alright, so now it's completed. All these images have been updated. So I'll go back to build. I'll go back to the OBJ level again. So here, nothing has been updated because we've already cached out that geometry. And if we go here, it still hasn't updated. That's because you need to go to render and then update textures. If it doesn't update correctly, you might need to manually reload the texture. So now you can see the underside is black and this side now incorporates that new light. So now I'll cache out this new version, save to disk. Now I'll go back to Solaris again and I'll set my view to the stage. The only thing you need to do here is go to the geometry sequence and press reload geometry. And now you can see it's got the new lighting that we added in. Now despite that annoying process, it does look like things are working. You're getting some reflections and some specular components. So the next step is going to be to stop him clipping through the floor. But before I do that, I do want to also show you the AOVs that I set up for this geometry. So if you drop in a Karma setup node, plug that in, you set this to be XPU parameters because we're using Karma XPU, and it should look the same as before, but the reason I added this node is so I can show the AOVs. So if you go to image output under AOVs, there's a few standard AOVs that work under the utility P world space, P camera space, depth, facing ratio, maybe even motion vectors. You can see each of these seems to work with these Gaussian splats, which is quite impressive. You can see all of these AOVs work at the moment, but I also added in some AOVs myself itself. And you can see these on the splats themselves. So this thing called geometry sequence, there's points. In here, if you scroll to the very bottom, you can see these prim vars called GS mask, GS diffuse, GS CD. All of these are extra AOVs that I added in case you need them. So if you go to extra render vars and do plus, you can add a new one called GS diffuse. For the format, it'll be color 3F. And for the source name, it'll just be GS diffuse as well. And you can set the source type from raw to prim var. Now if you go, you can view the GS diffuse, and that's going to just be the diffuse lighting that we baked in from before. You can also render the GS specular. It does take a while to render it properly, but eventually you should see it come through like that. The other one is GS mask, which is a float type. This is just 0 or 1 value. Is this a splat or is this not a splat? This is supposed to render white, but because it renders transparent, it's not the most useful at the moment. The other one is GS albedo, which again is supposed to be brighter than it is. Hopefully this will get fixed in a later Houdini build, so you can have a bit of fun in comp messing around with that. Alright, next I want to fix the clipping through the floor, but I also want to animate him and have him smash down on the floor with like a little simulation. To do that, I'm going to go back to the build again, and I'm going to set my view back to OBJ. Now I've got this proxy geometry, and this proxy is quite good for simulations. For this I'm going to use Vellum, so I'm going to create a new Vellum solver, and then I'm going to move him slightly above the ground, just a little bit above like this, so he can smash down. To get him to smash down, I need to set up some constraints to tell Vellum what this geometry is. There's a certain type of constraint in Vellum constraints called tetrahedral stretch. Tetrahedral stretch is for muscles mainly, but it treats it like a solid object. And this is a solid object, so I'm going to use that constraint. And then after here, it needs to be converted to tetrahedrons. You can do that using a tet embed node. So I'll plug this node in, but make sure the triangle scale is not too small or it might crash Houdini. Let's try this. So that's definitely too big. Make it a bit smaller. We can maybe do 0.1, and that's looking pretty good. So now I can plug that into the tetrahedral stretch and plug that into Vellum. Now viewing Vellum, see what happens? Just goes straight down because I don't have a ground plane. So on the Vellum solver, I'm going to add in ground position, and then that's going to hit the ground. There we go. And we're getting some nice floppy looking behavior like that. So now I'm just going to cache out this simulation using a file cache node. Before I cache it, I'm just going to delete all of these attributes because they're all taking up too much space. So on the Save Filters tab, I'm just going to do delete all attributes, delete all groups. And now that's going to keep everything lighter on the disk because I don't want too much storage. Save to disk. So now if we play back, we get this little animation of him hitting the ground. Note that we converted it to tetrahedrons. And tetrahedrons are a solid object. So if you look inside, you can see it's become solid with all these points inside. That's going to be quite good for deforming the Gaussian splats because they are also solid on the inside. So I'm going to take these splats and I'm going to deform them using this tetrahedron thing. The first thing I need to do is make sure they start in the same pose. If they don't, I'll show you what happens. So if you do a point deform, I'll plug in those points. I'll plug in the tetrahedral mesh and I'll plug in the deformed one. If you don't make sure they're in the right place, it does this. So what you want to do is copy this transform. I'll do actions, create reference copy, and I'll drag it here. So now it starts in the same position as this mesh did. So now when I play that back, you're going to see this Gaussian splat hit the ground and bounce around. So the next thing we're going to do is do the same thing to the original geometry before it was converted into tetrahedrons. I'm sorry this is getting a bit confusing, but it's just the way it has to be. This is the original geometry. I'm going to use the point deform node, plug it in, and now this is going to be the original geometry. And if you go to wireframe, you'll see there's nothing inside it compared to when it was tetrahedrons and it was crazy on the inside. So this one is the new cache you want to use in Solaris. I'm going to make a file cache node down here. I'll call it animated proxy, and I'll do the same thing for the deformed splats. I'll make another file cache. I'll call this animated splats. So these are going to be the two things that I use in Solaris next. I also want to add a velocity attribute because I want motion blur to be on this cache, and you can do that using a trail node. Set it to compute velocity. Then I'll add in the same trail node for the other one as well. On the first frame, the velocities, you get some kind of messed up velocities on the first frame. And that's because on the first frame, this cache is missing. So if you go to frame 0, there's nothing there. To fix that, in the load tab, you can just clamp the first frame and clamp the last frame as well. Now those velocities should be correct on those frames. So now I'm going to cache out this one, save to disk, and I'm going to cache out the other one, save to disk again. And just so you know, this is how everything is connected up. You can download this file on my website as well. But now let's get back into Solaris. I'll just copy the path for the animated splats because I'll need that later for that. The path, go to the output file, copy parameter, and I'll go back to Solaris. Back in Solaris, I'm going to set this geometry file to the path that I just copied. So that is now hitting the ground. And then we need the geometry of the proxy as well. So I'm going to change the sop path to the animated proxy. And that's just going to be the proxy falling down. And now, just like before, we bake out the lighting again using this new lighting condition. But this time, instead of using just the current frame, we do render frame range. I'm just going to render the first 24 frames because I don't have that much time. And now I'm just going to click render to disk. Right, it's been 30 minutes. It has finished rendering, going back to build, and I'll go back to the object level. So I just want to preview what those textures look like. I'll go to the animated proxy, set it to smooth shaded. Then I'm just going to do a UV quick shade again, plug that in and set it to the new baked textures. So you can see that now the lighting is moving around. Let's try it with the bake node, which I think I forgot to name, bake lighting. This lighting isn't moving because I forgot to set the file path to the new file path. So now we're getting that dynamic lighting. Right, so this lighting is valid only for 24 frames. So I'll just set this to 24 and I can cache this. Actually, I'll just delete this. I'll bypass this cache and just cache the animated version. So I'll go caching, save to disk, and there we go, animated splats, looking good. We got the dynamic lighting, we got everything working. Now we're ready to do a final render. So I'll go back over to Solaris and I need to set my stage context again. Geometry sequence, reload. That should be looking pretty good from Karma XPU. This is going to be the final render. It's going to be something like this. It's going down, going down, going down. In the Karma render settings node, just make sure I had motion blur enabled. I'll set it to velocity blur. So this will be my final render. I'll set a new camera and frame it a little bit better. And I'll set the resolution to 1920 by 1080. I also like to turn on the denoiser. If you go to filters, denoiser, you can set it to optics or NVIDIA. And by the way, make sure it's set to XPU rather than CPU or it won't render correctly. And to render, you just need to set it to render frame range. Let us render to disk this final animation. Right, the render has completed. We've got some new files to look at. I'm actually going to look at them in COPs. Why not? Let's do it. So on the OBJ level, I'm going to add in a new COP network. Inside here, I'm going to do a file node, and I'm going to load the frames from that video that we just rendered. Oscar award-winning video of this bug hitting the floor. If that doesn't knock your socks off, I don't know what does. And you can even add AOVs from this file. And now we have all of these that I accidentally rendered into the file as well. So you have the position, you have the camera, you have the depth, you have the facing ratio, you have the motion vectors. So hopefully this video was helpful and you can download this file in the description and I'll see you later.